So before we jump into full-fledged statistics, we got to get some basic vocabulary out of the way. You look at this first sheet of paper and there's a gazillion words and very few numbers, and that is really what the stats is all about. It's reading word problems over and over and over again. Can be very confusing. You got to just stick with it and keep reading. And really slow down your reading and wrap your head around it sentence by sentence is huge. You're definitely not going to read it as fast as you would read a novel. So before we get into it, we'll be reading, and it's a great chapter because it's very relative. We read about studies in the newspaper all the time that when certain things were observed, we noticed trends and so on and so forth. And a lot of what this chapter will teach us is when are those trends significant versus just coincidental. And so the first word that we have here is variability. And anytime you do a study of any type, there's variation. You could run the same exact study twice, but the results are different. They still might both point to the same potential conclusion, but the exact numbers and so forth, there's variation, and that's where the word variability comes from. So variability is nothing more than difference in outcomes. And there are 4 types of variability that we'll talk about. So here's one sense of variation. Pretend you're in physics class and you're dropping an egg off the roof of a school to see how long it takes to fall to the ground. Each member of the class is using a stopwatch to record the amount of time it takes to hit the ground. Will all the times recorded be the same? So pretend there's a class of 23 students. All 23 students have a stopwatch. The egg drops, they hit start, the egg hits the ground. Based on what they see, they hit stop. Do they all have the same time on their stopwatch? No. I mean, hopefully they'd all be in the same ballpark, but this is called measurement variability. It's variation that lies in the hands of the person doing the measuring. If I gave you each something to measure with a ruler, would you all come up with the exact same measurement? No, because there's some variation, there's some human error there, and that's called measurement variability. In scenario 2, we have 10 participants forced to eat the exact same diet and exercise the exact same amount in a study of weight loss. Will each of the 10 participants lose the same amount of weight? So I grabbed 10 people at random. I'm saying you're eating nothing but 5 pieces of broccoli 3 times a day, and you all have to run a mile 3 times a day. Will each of the 10 participants lose the same amount of weight? I think we know that the answer there is no. So why is there variation? If they're all eating the same thing and they're all running the same amount, why aren't they losing the same amount of weight? Well, there's a lot of different factors, right? Maybe their starting weight. Some people have a bigger body mass index from the get-go, so they might have more weight to lose than someone who's, rail thin and too thin from the start. So that's just called natural variability. We can't control a lot of those other factors. We're just in this particular experiment trying to control the diet and the exercise, but there's other natural circumstances that play into how much weight someone will lose in those scenarios. In the third one here, we have 100 participants. We're splitting them into 2 groups of 50. Group A, we're letting them sleep from 10 p.m. to 8 a.m. and wake up to take a test. Group B is kept up all night, so we're depriving them of sleep. And they take the same memory test in the morning. Will the groups perform the same on the memory test? I think the definite answer here is no. Even if they all got the same treatment, the answer would probably be no, due to natural variability. But this variability is likely caused by the condition that we gave them. Group A, we could probably say, will do better because they were on a full night of sleep, whereas Group B is sleep deprived, so they probably won't. This variation will probably be more significant than the natural one would have been, simply because we specifically took away something from them that we know would be a detriment. We took away sleep. This is called induced variability. Okay, if you induce something, you cause it, and we sort of tried to intentionally cause this change. And by doing something like this, we would essentially be trying to prove that a lack of sleep affects your memory. And then 10 students are randomly chosen from the cafeteria and asked what their GPA is. A second group of 10 students is chosen again, and their GPAs are recorded. So you grabbed 10 students and took their average GPA. Then you went ahead and sampled another 10 students and took their average GPA. Are the averages of those two groups going to be the exact same? Probably not, okay? It's almost like coincidental. It's just the luck of the draw and who we picked in the first 10 kids and who we picked in the second 10 kids. This is called sample variability. We did take a random sample, but by chance, one of those samples just happened to probably have a higher GPA than the other. So that's just sort of luck of the draw, the luck of who you decided or who you grabbed from your sample. So lots of different reasons why we can get different results. Okay, now the types of studies that happen, and we'll probably go back up and talk about some of these again, but there's different ways to run studies. In this first example, in order to get a feel for the most popular TV show, 20 students are chosen in the cafeteria and asked to report their one favorite TV show. So this like self-reported type stuff. This is a survey. Anytime you ask people to report their favorite something, or they report how many hours they spend doing something, that's a survey. So, and you know a survey. Keywords are like asked, self-reporting. You essentially, you know what a survey is. We don't really need to go into depth about it, but that's a survey. That's a type of study. In scenario 2, in order to study the differences in income level from state to state, 100 people are chosen from New York and 100 people are chosen from Massachusetts to report their income. And we're going to look at these 100 from New York and see what their income level is, and we're going to grab these 100 people from Massachusetts and see what their income level is. And we're going to compare, and based on these numbers, let's say New York, their average income was $87,000, and based in Massachusetts, let's say their income was $84,000. Okay? If that's what you found on average from your 100 people from New York, and this is what you found on average from your 100 people from Massachusetts, someone might conclude that Massachusetts people, on average, make less money. Now, only asking 100 people is a pretty bad study, simply because that could be just sample variability. That could have been luck of the draw, the reason the Massachusetts number was lower. But there also might be something to it. That might be because New York has New York City, and they maybe typically have higher salaries. You'd have to look at a lot there to see if that's a significant difference or not. You'd have to look at where they took their sample from. Like if all of these people were taken from New York City, then that's not really a good comparison to make on the states as a whole. But if you picked, 7 people or 5 people from upstate New York sprinkled around the state and 5 people from New York City, that would be better. And here, 5 people from, Boston, and then the other 5 sprinkled throughout the state, that might be a better sample. But nonetheless, the type of study this is an observational study. So we just took facts that really already happened. We just took facts, we took 100 people, and we looked at what already happened, which was their income from the previous year observational study. And we just kind of looked at those results of something that already happened. Whereas scenario number 3, you're going to see, we're actually going to create this scenario. We have 100 participants split into 2 groups of 50, and this is the same from above. So we're forcing group A to sleep, and we're depriving group B. So we are controlling this here. We are purposely controlling it and letting group A sleep and letting group B not. So everything else about the two groups is completely randomly separated, but we are 100% controlling something. And anytime you control a treatment, it's an experiment. Experimental study. Okay, so those are your three types of studies. And if we go back up to the variation ones, scenario 2 is kind of like an observation. I mean, you do control something, but you do it the same for everybody, and then you're sort of just observing results. This one is, of course, an experiment, and then this one is kind of like a survey, where we just ask them, or you could kind of argue this is observational as well, because you're just observing what are your GPAs, but also, or survey, because you're asking them to report their GPA. So that one could kind of go either way. But when these have come up on a test or a quiz there, and the Regents, they're pretty straightforward, one or the other. Sampling, how we choose a sample. So how do we choose these 100 people? How do we choose these 100 people? How do we choose these 20 students? So the way in which we sample is important. Sampling is the way we decide to collect data. You almost never can ask the entire world a question. It's almost impossible to, check the salaries of everybody in New York and everybody in Massachusetts and run an average, because you're inevitably going to miss some people. Some things are easier than others, but there's no way you're going to take the entire world and split them into two groups, one that receives sleep. You can't get everyone to agree to take a memory test. So unfortunately, you can't ever take the entire population and do studies. You have to just sample certain people. So the sampling is the way we decide how to collect data, who to collect data from. It is always important to do so randomly. So that word random will come up a lot. Random sampling is truly random. There's no bias, and we'll talk about bias in a second, versus convenience sampling is just the easiest thing for the person collecting data. So if we did maybe this cafeteria one, okay, random sampling would be every fifth person that walked in, we asked them for their GPA. That would be random if you grabbed every fifth person until you got to 10 people and you calculated their average GPA. And then you did it again. You got every fifth person and grabbed, the next 10 that came from that and calculated their GPA. What would actually be even better is if every fifth person, you put the fifth person in group 1, and then the 10th person in group 2, and then the 15th person in group 3, and the 20th, or group 1 again, and the 20th person. So every fifth person you grabbed, but you separated even that into two separate groups. That would be very, very random. Versus convenience in a case like that would be like, you know what, the first 10 students who walked in, they're in a group. The next 10 students who walk in, they're in a group. That's not as random. And you could argue that there's some bias involved in that, because if the first 10 kids who walked in, you just took them all and put them all in the same group and looked at their GPA, well, there's a pretty good chance that those 10 kids are all coming from where they just were, which was together in an AP calculus class. Well, guess what? If those 10 kids that all just came from an AP calculus class end up in the same group, then their average is probably going to be higher. And so you've introduced a bias by not having it, well balanced, I guess. Another thing would be, like, if you wanted to see who the, favorite baseball team was, right? And you were going to try to see who's everyone's favorite baseball team, right? I don't know what the best random way to do it, but one random way to do it would just be to, randomly grab a list of people from each of the 50 states and grab one person from each of the 50 states, or 10 people from each of the 50 States scattered all around. Or just grab social security numbers of the entire country and just grab 50 people, and that would be totally random because the social security numbers, I would have no idea where they came from. But somehow get in touch with 50 people from the entire population of the United States and ask them who their favorite baseball team is. That would be truly random. However, if I went and stood outside of Fenway Park and I said, who's your favorite baseball team, to the first 50 people that walk past me, that would introduce a bias, because you could argue that those people coming out of Fenway Park, for those of you who know baseball, would be Boston Red Sox fans, because that's where the Boston Red Sox play baseball. So that would undoubtedly be a bias. You wouldn't want to grab people from outside the stadium. You wouldn't even want to grab 50 people from Boston, because of course there would be a bias there as well. You would want them to come equally as likely from any part of the country, and then you would have a good idea of who the favorite baseball team is. Alright, so that's the end of the vocab, and then just something on how random sampling is done. So this first chart gives us, this is a basketball team, let's say. There's 10 people on the team, person number 1 through person number 10, and here are their heights, okay? There's a population mean. And that would be, mean is average. So I could find the average height of these 10 people simply by adding them up and dividing by 10. 70 plus 68. And the only reason I can do this is because this basketball team is a somewhat small number of people. So I can actually come up with the actual average. So if I add them all together and divide by the 10 kids, the average height of the entire team, I know for a fact, is 65.6. The reality is a lot of times when we're doing data and we want the average height of people in general, we can't take the height of every single person on this planet and add them together and divide by the total population. It's impossible to collect all of the data, essentially, and that's where samples come in and help us. And we try to make these samples random. So we're going to randomly select from these 10 people. Well, how do you randomly select? So this says use the random number table below to randomly select 5 heights from the list. Start at row 7. So 1, 2, 3, 4, 5, 6, 7. So starting at row 7, we want to select random heights from that. Okay, so these random tables, we're going to assume that these are person number and 1, 2, 3, 4, 5, 6, 7. And we'll do like 2-digit numbers. So this would be person number 89. There is no person number 89. We only have 10. This would be person 97. This would be, well, 89, 79, person 33, person 43, person 78. Here's person 8. So we're trying to select 5 heights. We just selected person number 8, just because that's what the random table gave us. There's person 73. Here's person 5. Person 65, 22, 78, 15, 52, 24, 66, 81. I'm looking for numbers between 1 and 10. 97, 85, 73, 23. Keep going. Here's person number 7. 11, 69, 89, 93, 14, 75. Person 0. Shoot, I don't have them. Person 28. Person 8 again, but I've already used person 8, so I have to bypass that one. 27, 53, 86, 73, 77. So I'm just going to scan. Here's person number 1. So I'm up to 4 people. Person 11. Boy, oh boy, this is taking forever. Can't remember if this... Here's person number 3. Okay. So... could we just put these 10 people in a hat and draw out 5 names? Absolutely. That would be very random. But there's these number tables that they have us use sometimes that I think we can all agree it was completely random how these, like a computer came up with these random lists of numbers. And so it was completely random that these were the 5 people that we chose. You couldn't just say, oh, randomly pick 5 numbers between 1 and 10 and have a person do it, because people inadvertently might pick 7 because lucky number 7, or they might pick 3 because 3 is a common favorite number. So you can't really use people to just, because even though you think you're choosing randomly, you'd be surprised at the tendencies just based on human psychology. So we let a computer do it, and here's our 5 people. We're just going to calculate the average height of those 5 people to be representative of the average height of the entire population of the team. So I'm just going to take those 5 numbers, 70 plus 60 plus 65 plus 58 plus 62, and divide by 5. And that average height, the sample mean versus the population was the whole 10-person team. The sample mean is only 63. So are we surprised it's not the exact same as the population? No. That's just sampling variability. That's just luck of the draw based on the 5 people that we chose. That sample is not going to be exactly the same as the population, but it should be typically in the ballpark, unless we got incredibly unlucky to pick really short people. But it should be in the ballpark. But it should make sense to you that if you do the average of the entire population, it's probably never going to be exactly the same as the average of the sample you chose. And again, that's the sampling variability, kind of the luck of the draw of who we chose, that we talked about on the front side. And then here's another random table. What are the ID numbers for 10 students chosen at random from a population of 780, based on the following string of random digits start at the left? So I'm assuming that each one of these 780 students, we'll just pretend, the first student is ID number 001, and through the 780th student will be 780. So we're going to randomly choose 10 students to sample. So that would be student number 278, student number 167. The next one, student 841, isn't in our range. We don't have 841 students, so that would be out. Student 601, student 322, student 735, student 213, essentially any number between 1 and 780 we can grab. Student 774, student 101, how many students is that? 1, 2, 3, 4, 5, 6, 7, 8. Student 631, student 268, student 000 we actually don't have because we started at 1. 536, student 455, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops, I went, oh boy, I went 1, 2, 3, 4, 5, 6, 7, 8, 9. I only wanted 10 kids, so that's what I got. So let's pretend all 780 students were in a list from 1 to 780, and we're going to pick these 10 students that are those numbers on the list. And then those are the 10 kids we would sample, and then we would all agree that those are as random as we can get, outside of putting all 780 names in a hat and mixing them up and pulling out 10. That's a very random way of choosing 10 to sample. Okay? And the last one here, suppose that you want to randomly select 60 employees from a group of 625. Explain how to use a random number table or a calculator with a random number generator. We're not going to talk about that. We're going to talk about this number table again. So essentially, we would identify each person with a number from 001 to 625. Okay? Everyone has to be a 3-digit number. And so then we would look at every set of 3. Look at every set of 3 numbers and select the first 60 that fall between 001 and 625. And the first 60 would correlate to 60 employees, and then that would be our sample of 60 from the 625. just as a disclaimer, when the Regents first came out, this random number table was a thing that was stressed to us as being, it was new, so we needed to wrap our head around it, and it was stressed to us as being something that we should teach. Now, in the 4 years since the Common Core has changed over in Algebra 2, I've never seen this on a test. So I want to show it to you so you've seen it before, but at the end of the day, I will be honest with you, I've never seen it on a Regent, so I wouldn't get bent out of shape about it. But certainly ask any questions tomorrow to clarify. The big thing here is a lot of the vocab that goes into reasons for variation and the types of studies that we will be looking more into this chapter.